All right. Video here on Laplace of x double prime. If you just watched the one on x prime, it's pretty similar. So Laplace of x double prime, well, I plug it into the Laplace formula. And just like we used dir and int, integration by parts, on the previous one, we're going to do the same thing on this one. Now, what do? I'm actually going to do a double diagonal and then use my escape method on this one. And it works out pretty well. So what do? I do a dir on this piece and an int on this piece, and I'm going to int until it comes back to x. Notice when I take the derivative, pretty simple, s and s squared with a negative. Here, x double prime, x prime, x. When I integrate at the end, I come back this way. I do my alternating positive, negative, positive. And notice this one has a negative 2. That actually works out pretty nice because when I do all of my multiplication, those guys are all positive. The other thing I'll say that you maybe don't do or don't remember, well, the integral, we typically have that back integral, that escape method integral would be negative, but I always follow the signs of the arrows, so I always alternate. Plus, this one was minus, so when I do my escape method on this, I actually get a plus. So, what do I get when I do all this stuff? Just roll with this. Write down if you want, or you can just listen. So, what do I get? I get e to the negative st times x prime of t plus s times e to the negative st times x of t. That's these guys, those first two diagonals. And then I get plus, I get s squared, and then times the integral of these guys. There should be a t right here. What's that? Yeah, that should just be a t right there. Anyway, what do we get? I get all this stuff plus s squared times integral from 0 to infinity of this product, which is what we got from our escape method. All right, so I need to evaluate these from 0 to infinity. What I'm going to argue at first, infinity. I got an e to the negative infinity and e to the negative infinity for those two. They're both going to go to 0. Okay, when I plug in t equals 0, well, this goes to 1, the e to the, because I get e to the 0. And then same thing here. I get e to the 0 when I plug in t equals 0. So what do I get? I get a 1 and I get an s. Then I also need to plug in t equals 0 here and here. When I plug in t equals 0 here, I just get 1 times x prime of 0. And when I plug in t equals 0 here, I get s times x of 0. Then this thing right here evaluates very similarly to the way the previous one did. I plug in infinity to this thing, and I get e to the negative infinity, which decays away. And then I plug in 0, and I get x of 0 times e to the 0, which gives me just a 1 right here, and an x of 0 with an s squared. Oh, I'm sorry. Did that wrong. I'm not plugging in infinities. Bam. This is my mistake, and I can't backtrack 10 seconds. This is just the Laplace of x of t. Integral from 0 to infinity of x of t times e to the negative st dt. Bam! That's the Laplace of x of t, which we're just going to replace with x. Sorry for that little bobble there. Anyway, so I get s squared times big S. So what do? I just reorder all this stuff. These guys got a negative. I get s squared x minus s times x of 0 minus x prime of 0. And that gives us these three Laplace transforms. If you haven't written these down yet, you should have these all written down because we're just going to use them. Now that we got them, we can use them. We also have these two from previous work that we've done. And next, we are going to go ahead and actually solve a problem.